Hello, my name is Tom Preston, and I'm here to do a technical demonstration of the Evatronix scanners. We're going to look at a basic setup of the Evatronix scanner with the column-mounted scanning setup with the turntable. We're also going to look at using the Evatronix scanner setup, and also what we can do with the robot and cobot scenario of setup. So to begin with, I'm going to start off talking about the Quadro, which is the multi-field of view 3D scanner produced by Eviscan. It's a heavy-duty Quadro, is really nice 5 megapixel cameras, 4 sets of them. It has laser indicators for easy positioning, a carbon fiber frame for stability, high point density for maximum geometry projection. It has easy tripod mounting, and versatile 2 range views, as previously stated. So we can go from 370 by 265 by 150 to 210 by 145 by 90 with 40 points per millimeter and 161 points per millimeter squared. So really high density for kind of really high accuracy scanning, but also high field of view for fast scanning as well. So a really versatile piece of equipment. So just having a quick look at the setup here, we're looking at the calibration process of the scanner. So aligning this with the calibration plate. This is quite a simple process where the 2 laser lines are aligned and there's a number of shots taken at different distances from the camera to create a measured bounding box within the environment. This allows for high accuracy scanning within the kind of area of scanning. You can see here it's a very far field as well, so we have over 500 mil of distance from the scanner to the calibration window. So this is just the point of object scanning in question. So we're scanning a Continental tire, as it's kind of one of the main customers of the Evatronix scanners. So we can see the tire being mounted on the turntable on a board as a simple setup, and the scanning process taking place. So it uses a fringe projection method of scanning where a barcode-like projection is done over the object, and then that barcode is moved across. In this way, we can obviously calibrate to capture all of the points in that field of view. So once we have completed the scans, we obviously need to take it into the Evatronix software. So there is there's 10 steps on either side of the wheel here. So there'll be 2 different points of view taken into account, and then we will align that within the software and create a cohesive mesh. So looking into the software now, we can see the 4 different tables for the different points of views that we used to scan this tire, and all the different meshes used to create this object as such. So each point of view, each snapshot is aligned within the software using the aligning tools, and then we can convert this to a singular mesh. So now looking at the merged object, we can see the high resolution of this scanner, having a look at the detail that we can capture within here. Really nice for reverse engineering of tire structures, tread analysis. All types of processes can be implemented with this type of setup. So now looking at the Evatronix scan software, we can look at how we can automate this further, so make it less user-based to set up, more automatic and easier to use. So looking at a quick video demonstration here, we can see the Evatronix scanner setup, which is using a 4-axis setup here connected to a laptop. Part is placed onto the turntable. We have auto calibration where we can place the calibration plate onto the turntable as well, making it a much faster process for calibration. We scan the part very easily at multiple different views, so capturing as much data as we can from the part without human interaction, very much automating the process for quick and easy capture of the data as such. And you can see here the software all aligning the scans automatically whilst using this setup. So what is the Evatronix? It is designed by Evatronix, a proprietary piece of hardware. It's a 4-axis 3D scanning system, enables measurement and quality inspection of variable parts with minimal operator involvement. It's very good for repeatability, it's fast, it's precise. It makes the inspection task that much easier for a user to do as such, and it really makes the scanner work for you that much better as such. It can be set up with the Quadro or the Optima. So in both ways, we can use the different fields of view, but also possibly use the Optima as a cost-saving exercise as well. So the advantages of the Evatronix is the auto-calibration, which makes it a faster process for calibrating the scanner, making sure your measurements are accurate. The automated scanning procedure, so setting up a procedure for scanning the part as such. This has got some proprietary tools built into the Evatronix software. The ability to define measurement sequences allows you to then build that into an inspection program as well. With regards to Control X, you can do simple measurements, pull that into the Geomagic Control X software, and automate the inspection report as well. It's possibility of simultaneous scanning of several small components, so you could set up multiple parts to capture maximum parts per scan, which is very, very quick and easy to do. So the technical data of the Evatronix is its maximum dimensions are 250 by 65 by 250. So what you can fit onto that build envelope. It allows for 30 kilograms. It allows for 10 kilograms if you don't want it on the turntable. It's got 4 axes, 360-degree rotation with a 700 millimeter linear movement. Vertical is at 800 millimeters, so minus 10 degrees to plus 85 degrees. So really getting full view of the part in question. It's a stepper motor type, and it weighs about 51 kilograms. So really lightweight in considering the scale of this part, this system. The scanning characteristics, so it can be set up with a blue LED or RGB LED system. So again, using the Optima or the Quadro setup, and allows for quick and easy scanning of different fields of view. It can be successfully applied to comprehensive quality analysis and shape dimensions. It's an ideal choice for fast, repeatable, and accurate digitalization inspection of cast, mold, and forged parts. So moving on, we're looking at how we can automate this process even further, even using robots or cobots as a solution for scanning. So inspection using cobots and robots makes it, using robot arms, for instance, makes the part that much easier to automate the scanning process within a production line. The precise position of robot arms allows for repeatability and control of the workspace is much easier. Identification of position of objects in space is really easy as well with regards to using the software as well. So two solutions that can be used with a robot arm as such is scanning with the scanner on the robot arm or having the part located on a robot arm. So just a quick video showing the two solutions. We have a KUKA robot arm here showing the scanning process in an inline inspection. So you can see the scanning process taking place with the different positions of the scanner, using the target markers as a reference device for more easily alignment of the scan data. So you can see how quickly the scan can be built up and those measurements can be created. Again, using the KUKA system makes it that much easier and more friendly to capture this information. So another solution would be if we had the part on a robot arm. So this is using the Quadro system with the part on a robot arm. Again, using those index marks to allow for quick and easy alignment. The robot arm allows for positioning in the best field of view, and the scan taking place quite easily to capture that information. So in both scenarios, we're looking at making this process that much faster and easier and more repeatable for a particular procedure as such. And obviously, we can help define what the necessity of your process is and give you advice on the best possible solution for that automation. So just a quick look at the comparison of the high-resolution Evatronix scanner compared to a low-resolution 3D scanner versus 5 megapixels versus 1 megapixel. So the Quadro versus a typical scanner that's out there right now. So we can look at the 5 megapixel camera and see the resolution accuracy that we're getting from here as a mesh versus a 1 megapixel camera. So a higher field of view, but still much higher resolution with 10 million polygons. Lower field of view, lower resolution, 1 million polygons, still taking approximately the same time, but the accuracy and the quality is better overall. And you can see right here, the detail that we're capturing on a tire is amazing. It's really capturing all of the fine details that you could possibly want for reverse engineering or inspecting this type of part.